In today's session, we'll be seeing about prime factorization. What you are going to see? Prime factorization. Okay, and I guess you know that what is meant by factor. For example, factor is a number which divides the given number exactly. The number 2, what are its factors? The number 2 and its factor 1 and 2. The number 4, what are the numbers or its factor? 1, 2 and okay. The number 5, what are their factors? 1 and 5. And the number 9 I'll take. What are their factors? 1, 3 and 9. 12. 1, 2, 3, 4, 6, 12. 15. 1, 3, 5, 15. Then what we done is factorization. We have done. We have factorized the numbers. We listed out the factors of the numbers. Okay. In this, prime number means what? Do you know? A number which is having only 2 factors is called as prime number. So we have the prime number list. Starts from 2, 3, 5, 7, 11, 13, 17, 19 and so on it goes. Okay, these are all prime numbers, and prime factor means combination of these two. Here we say 1 and 2 are factors of the numbers. Among the factors, who is prime? This is the prime factor of 2. What are the prime factors of the number 4, can you say? Two alone. The prime factors of 5? 5 alone. Okay. Like, but one is prime, one is also prime, right? No, one is neither prime nor composite. Okay, so in the list of prime numbers we should not include one. Okay, and then the prime factor for 9, three. What are the prime factors of 12? 2, 3. That's all. Prime factors of 15, 3 and 5. Now, the prime factorization, meaning that writing the given number as product of primes, or else positive integral powers of product of primes, or else simply we can say the integral powers of product of primes. That is it. Okay, but maximum we use positive numbers only. Say for example the number 12. Since all these numbers are factors, we can represent 12 as multiple of any other number. But is it possible to represent this 12 as only product of 2 and 3? Only 2 and 3 should be there, and the integral power of 2 and 3 can be taken. Positive integral power. Positive integral power, I mean what? It is a positive power. Power should be a positive number. Is it possible? Can you say? For that, we will be doing this L division. This kind of factorization is called as prime factorization. Whatever the given number, the composite number, given composite number or the prime number also will do. Prime number, prime factorization is really easy. The number itself will come. Okay. Now this composite number, we should start dividing it by the least prime factor that can divide this. What is the least prime factor that can divide 12? 2. Then when you divide 12 by 2, what you will get? 6. Again we continue the process. The least prime factor that can divide 6 is 2. When you divide 6 by 2, you will get 3. And that is it. There is no prime factor that can divide this 3. 3 we can divide, but if we divide by 3 means here 1 will come. That we should not mention in the product because 1 is not a prime. So we stop right here and we multiply all the numbers. So the procedure is, we will be dividing the number until we get a prime number. Okay, we will be dividing the given number using a least prime factor until we get a prime number. Okay, then 12 can be represented as 2 into 2 into 3. That means 2 square into 3. That is how this prime factorization works. Okay, let us take another example. 105. We should start dividing this number by the least prime number that can divide this number. Don't say 5. Below 5 any numbers are there. You can start with 5 also, not a problem, but as per the concept, the least prime factor we should begin with. So check whether this number is divisible by 2 or not. No, it is not. 3, will it be divisible? Divisibility rules we studied, remember? So 3 it can be divisible. We will use 3 first, not 5. Okay. So 105 divided by 3. How will you divide? 3 3s are 9. Carry over 1. That makes this 5 as 15. Then 5 times 3s are 15. Then the least prime number that can divide this, don't say 7. Below that, any prime number? 5. Look at this number, man. 3 is possible? No, not possible. So we'll start with 5. 7. 7 is prime or not? Yes, we got a prime number. So this 105 can be written as 3 into 5 into 7. That is the prime factorization of 105. So I'll tell you once again. Expressing the given number as product of positive integral prime numbers, prime factors, is called as prime factorization. Okay. See the number 12. Though all this number 4, 6, 12 and all factors, it will not be a part of this prime factorization. Only using prime numbers and powers of it we should use. Okay. Clear? Okay. Now, can you list out the factors of the number 11 to 15 except 12? 11 to 15, write the factors of the number. Have you written everything? Shall I erase this side? Done. What is the prime factor of 11 you found? 1 and 11 you say. Okay. But you said the prime factorization of 11 is 1 into 11. But that is wrong. What I said? 1 should not come when you are doing prime factorization. I asked you what is the prime factorization of 11. I asked you what? You said factors of 11. Okay. Now 12 we already done. 13. Can you express 13? What is the prime factor of 13? Prime factor of 13. Thirteen itself is a prime. That is why I told you to list out the factors. 13 is prime number or not? It is. So what is prime factorization of this 13? Simply 13 alone. 14. What is prime factors? What are all the prime factors of 14? 2 and 7. Can you express this as a product of primes? 2 into 7. Okay. What is prime factorization of 15? 3 5s are. Let me take somewhat far fairer than 15. 45. What is prime factorization of 45? You don't need to list out the factors of 45. You do the prime factorization and tell me. Using the L division. Do it.